question is not trivial by any means. Oh, let me copy it first. So 10.95 over 1 plus 3.51 e to negative 0.029x. Good. How do I solve this equation? What would be our first step? What do you think? First step. I'm going to help you. What does that mean? What am I getting at?
Divide by 8.
Multiply by 8. Cross multiply. It's a proportion. That's why I put 8 over 1 for you to see fraction, equal symbol, fraction. Only in a proportion I can cross multiply. So 8 times this equals this times this. Good. Remember, I need this alone. So now I need to simplify. Clean it up. What will be my next step of cleaning it up? In the process of cleaning it up, making it very simple. What will be my next step? What do you think? Give it a shot, please. We divide by 8. Good. What will be the next step? In the process of simplifying everything, step by step. What will you do?
Would you do the natural log?
Subtract. We are so far away. We cannot apply natural log to a sum. It will not take us anywhere. I have to get rid of 1. So subtract 1 from both sides. So 10.95 minus 8 over 8, subtracting 1. So I'm going to write it one more time. So this is 2.95 over 8. What is the next step towards cleaning it up before I can apply log? What should we do now before we apply log? One more step. Anyone? We divide by 3.51. We have to clean it up to the bone. Only now we can apply log. But I'm going to flip this first, and then we can apply log. You cannot apply log to a sum. You cannot apply log at any level, at any step, but now. But I'm going to rewrite this first. 2.95 over, I'm going to multiply 8 by, what do I get when I multiply 8 by 3.51? I think I get this. 8, 0, and 4. Yes. Only now I can apply log. So natural log of e negative 0.029x equals natural log of 2.95 over 28.08. I bring this down. Negative 0.029x, because I know natural log e is 1, equals natural log of 2.95 over 28.08. And now I divide by this number. That's what I said. This is not a trivial type of equation. A lot of steps happening here. So, natural log 2.95 divided by 28.08, and then divide, don't forget parentheses, it's a negative number. Good. So this will be added, so 77 roughly, x approximately 78 years. And when will the world population reach 8 billion? So 1949 plus 78 years. So it appears that in 2027, that will happen. Of course, assuming that the model still holds. We don't know. Good. Let's go to back to some more exponential and log equations. Okay, so here we have the exponential equations, 1 through 48, and then we have logarithmic equations on the next page. Anything you'd like to work on from the exponentials? Anything from the exponentials? Anyone, please?
We do 22.
Yes, 22. In 22, we have e to x plus 4 over e to equals 1 over e to 2x. Perfect. Always remember, if both sides can be presented with the same base, it's always easy. So e to x plus 4, the same thing with e to negative 2x. 1 over e to 2x is the same with e to negative 2x. So therefore, if the bases are the same, the exponents and the numbers or expressions are equal, then the exponents have to be the same. So then x plus 4 equals negative 2x, and I move x, so I get x equals negative 4/3. Does it work? Very easy to check. Of course it does, but very easy to check. How will I check this? Well, with the graphing calculator, I determine e, in parentheses, x is negative 4/3, and then plus 4, close, and set it, and just enter. And then on the other side, I have 1 over e to, in parentheses, 2x, 2 times, in parentheses again, negative 4/3. Be careful. And I have to get the same answer. If I don't, something is terribly wrong and my solution is incorrect. So I plugged in on the left, I plugged in on the right, both numbers were equal, therefore x is indeed negative 4/3. Good. Anything else? So please remember, it's always easy when both sides can be presented with the same base. There is no need to apply log. You're making it more difficult and longer. Will you get the same answer? Of course. Of course. But it will take you 5 minutes versus 1 minute. Now, if they cannot be presented with the same base, it's a totally different story. But if they can be presented with the same base, you should always make the effort. Good. Next question, next problem. Anything else here? Any other exponential?
Can we do 44?
Yes, of course. 44. In 44, we have to notice that this is quadratic in form. In other words, I'm going to denote this by y because this is y squared. When you raise e to the x power to the second power, you get e to copy the base and multiply the exponents. So that's why if I denote this by y, this is definitely y squared. So then y squared minus 2y minus 3, this is very easy. We just had the same thing into y minus 3 and y plus 1. So I get two options for y. But nobody cares about y. We have to give the answer in x. So I denoted by y e to the x. So e to the x is y. So then this equation becomes e to the x equals 3. And this equation becomes e to the x equals negative 1, which is, I know it's not possible. Because I cannot apply natural log here to negative numbers. So this can never happen. But when I apply natural log to both sides, I get natural log 3. So there is a solution. So x is indeed natural log 3, and this is the only solution. And of course, you can go back and check. Okay. Let's look at a, unless you wanted to go back, let's look at the log equation. Anyone would like to choose a log equation?
$79.
Okay, perfect. 79. Common log of 3x minus 3 equals common log of x plus 1 plus common log of 4. Am I correct? Am I copying from one problem? Yes, I did. Okay. You know me. 3x minus 3 must be greater than 0. X plus 1 must be greater than 0. So this one x greater than 1 and this one greater than negative 1. The intersection is, oh, I didn't mean that. The common domain is 1 to infinity. How do I know? Negative 1 to infinity, 1 to infinity, they overlap at 1 to infinity. Good. So if I don't get a solution that is a number strictly greater than 1, I cannot accept it. Okay. So the left-hand side is log of 3x minus 3. The right-hand side, if you remember how to condense this, is log of 4x plus 4. How do I know? Log plus log is log of the product. And when I multiply 4 by x plus 1, I get this. 2 logs in the same base, of course, are equal to each other. The same like with exponential. This piece has to equal this piece. There is no other way. So 3x minus 3 must equal 4x plus 4. I move 4x. I move 3. So then x equals negative 7. Not so fast. Ooh. No way. This equation has no solutions. I got a number that doesn't fit in the common domain. So negative 7 plus 1 is negative 6. Log cannot be applied to negative 6. So this equation has no solutions. I was not able to find a number that is strictly greater than 1 as the solution of this equation. Therefore, it has no solutions. If you remember, you either state the common domain or find the common domain where they overlap if there is more than one log. If there is only one log, then you have nothing to worry about, just one log, one domain. Here I had two options, one for here, one for here, but I have to find a common domain. Both have to exist, not just this or that. Both have to have to exist at the same time. So you either state a domain, find a common domain, and then you check, or either one, but you have to choose one. You must remember to check back in the original problem, because if you get an answer and you don't check and you realize, oops, wait a minute, the equation has no solutions, you're not going to get full credit because you are considering a solution that is incorrect. You're going to get points for your work, but not for the overall problem. Any questions? Okay. We have time for one more, and then we can stop. Anyone would like to choose another, or I will? Okay, I'm going to choose 70. In 70, we have log base 6 of x plus 3 plus a log base 6 of x plus 4 equals 1. The same as before, x plus 3 greater than 0 and x plus 4 greater than 0. This is greater than negative 3, and this is greater than negative 4. Negative 4, negative 3, so I have to choose this. So then the common domain is negative 3 to infinity. If when I'm done, I don't find a number between not negative 3, between negative 3 and infinity, then the equation has no solutions. So I will condense. Do not state a domain on the condensed form. The domain or the common domain has to be stated on the raw equation. So log base 6 of x plus 3 times x plus 4 equals 1. This is equivalent to 6 to the first power equals this. So I will distribute x squared plus 7x plus 12 equals 6. 6 to the first power equals this. So now x squared plus 7x plus 6 equals 0. Easy to factor into x plus 1, x plus 6. Get two options as negative 1 and negative 6. Not too fast. So I'm checking here. No. Yes.